Yeah. Yesterday we have discussed about some fundamentals of Palo Alto Firewall, right? Today we are going to discuss about the packet flow inside the firewall. Okay. మనకి ఎలా అంటే ఒక ట్రాఫిక్ ఫైర్వాల్కి రీచ్ అవ్వగానే హౌ ద ఫైర్వాల్ విల్ ప్రాసెస్ ద ప్యాకెట్ ఇన్సైడ్ ద ఫైర్వాల్. ఓకే, what are the steps the firewall will take if the firewall wants to send the packet out. Okay, and there are multiple steps that firewall has to be gone through that whenever we the traffic is reach on the firewall. And if anything is happened in between these steps or anything is happened between these stages, the firewall will discard the packet and it won't send out the packet. And if something is happened in between, the firewall will discard the packet. We can see step by step how the firewall will process the packet. Let me draw the diagram. Okay, let's suppose this is our firewall, and let's take this is our Windows machine, and our firewall is connected to the internet. This is our normal topology that we are going to discuss for the packet flow. Okay, and for suppose let's take this PC is connected to one of our my interface on the firewall. Let's take it is Ethernet 1/1, and it is and the other interface what that is connected to the internet is Ethernet 1/3. And also we have discussed about zones, right, yesterday. So what I am doing is I am creating a one zone and including this PC in the particular zone, and also I am creating one more zone for this outgoing traffic. Okay, so for suppose let's take I have an created an inside zone for our internal network, and also I created an outside zone for outside traffic. Okay, and whenever the traffic reaches, I am trying to ping నేను ఏం చేస్తున్నా అంటే from this PC I am trying to ping the internet means 8.8.8. Once this traffic reaches the firewall, what will happen inside the firewall? Okay, what will happen inside the firewall when you are sending some traffic to reach the internet? The firewall will is in the between, right? So it will be taking the traffic, and how the firewall will process this traffic inside. Okay, and once the traffic reaches the firewall, the first step, the first stage it is going through is an ingress stage. Okay, ingress stage. And second is an slow path. Third is an fast path. Okay, this is a third step or third stage. And apart from that fast path, we'll be having application identification stage. Fifth stage is an content inspection. Content inspections, if there are any hacking happening or if there are any malware detections, the firewall will do an content inspection for that. And after the content inspection, the last stage is egress. Okay, once all the stages is completed, then only firewall will egress the traffic out. Okay, whenever the traffic reaching the firewall, it will go through all these processes, all these stages. Once all these stages are passed and once all these stages are completed successfully, then only the firewall will egress the traffic out without any issues. In between, if we have seen any issues or if we have seen any errors, or if your firewall is blocking any of the traffic, the firewall will be discarding the packet in between without completion of these stages. Okay, let's go ahead with one by one stage. Okay, the first stage is an ingress stage. Sorry guys, something is happening in my yeah, first stage is an ingress stage where the traffic receives on the ingress interface, right? Ethernet 1/1 is my ingress interface. So the traffic which receives on this interface is an ingress stage. Okay, what happened in the ingress stage means whenever we receive the traffic, will be receiving the pack in the form of packets, right? Like we can receive L1 packet and L2 packet, L3 packet, L4 packet, and we'll be having our actual data. Okay, the traffic will be received in this form. So what firewall will do in this ingress stage means it will be extracting the tuples. Okay, we'll be calling tuples here. What will be extract means it will extract from these packets. Okay, whatever the traffic, whatever the packets that received on the ingress, from these packets it will be extracting some information. What are the information means, first thing is an it will extract source IP and destination IP, source port, destination port. Oh my god, just a minute guys. Okay, and the fifth one it will be extracting is we will be having the traffic is entering on this ingress interface, right? From this ingress interface what it will be extracting is an source zone. Okay, it extracting the source zone and also the protocol. Okay, what is the protocol that is using in the L3 packet, we will see the protocol, right? So it will be extracting all this information. In the firewall in the Palo Alto, what all this information will be calling as an will be calling as an tuples. Okay, whenever the traffic receives the receives on the firewall, it will be extracting all these tuples. Okay, and once is extracting all these six tuples, here we will be having six tuples, right? Source IP, destination IP, source port, destination port, source zone and protocol. These are the six tuples that are going to extract from ingress stage. Once it extract the six tuples, what it will do is it will be check if there are any ingress errors are there with these six tuples. Okay, if there are any ingress errors, or it will be verifying for any checksums, right? Checksum means it will be doing any if there are any errors identified in these packets. Okay, it will be do the checksum, and if there are no errors it will be proceeding further. And if the firewall sees errors in this ingress test, the firewall will drop the packet here itself, it won't process further. Okay, if there are no errors it will be proceeding further. And also this is for the normal traffic. If this is for the normal traffic, for suppose if we have any tunnels, okay, IPsec tunnel or SSH tunnel between these our client mission and the firewall, what it will do is the packet will received in the form of మనకి ఇక్కడ ప్యాకెట్ ఎలా వస్తాయి అంటే టనల్ ఉన్నప్పుడు ప్యాకెట్ అనేది ఎన్క్రిప్టెడ్ ఫార్మాట్లో వస్తుంది. ఎన్క్రిప్టెడ్ మీన్స్ వీ డోంట్ నో వాట్ ద ప్యాకెట్ కంటెంట్స్. మనకి ఇన్స్పెక్ట్ చేయాలంటే ఫైర్ వాల్ అనేది డీక్రిప్ట్ చేయాలి. సో whenever the traffic comes with an IP any of the VPN form, okay, if packet reaches the firewall has reaches the firewall in encrypted format. Okay, if the firewall reaches the if the packet reaches the firewall in encrypted format, what it will do is the firewall will decrypt that traffic. Okay, will decrypt that traffic, and it will be again extracting these tuples. Okay, this is for the normal packet. If there are no if there is no tunnel between these our client machine and the firewall, it will directly extract the tuples. If there are any tunnels between our client machine and the firewall, it will decrypt the traffic, and it will again extract the tuples. Okay, it will extract the tuples after decrypting. These are the things that is going to do the firewall in the ingress stage. And after the ingress stage, what it will do is it will be moving to the second stage, slow path. Okay, before moving to the slow path, what it will do is it will be check if there are any existing sessions for this tuples. Okay, existing session means in the firewalls we'll be having some flow tables. Okay, the firewall will maintain the flow table or session table. Okay, in this flow table or session table, what it will be having is it will be having client to server traffic, as well as server to the client traffic. Okay, in the flow table we'll be seeing these sessions. Okay, if it is an first packet, the firewall will don't have an session in the flow table or session table, so it will be directly moving to the slow path. If it is an existing session, okay, if it is an existing traffic or if it is an existing session, the firewall will be matching the session with these tuples in the flow table or the session table, and it will be skipping this slow path. Okay, slow path is mainly for session installation, and if you have already existing session for the traffic. Okay, the initial packet, right, whenever you send an for suppose if it is an TCP traffic, we'll be sending an SYN packet, right? Whenever the firewall receives a SYN packet, that is the first packet. If you receive the first packet, that will be moving to the slow path, because there won't be an any existing session, so it will be moving to the slow path. If it is an if there is no if there is an existing session, okay, if SYN packet received, and again we'll be getting an SYNAC packet from the server, right? So for that SYNAC packet, we'll be having an existing session. Okay, we'll be having an existing session. So in that case, what it will do is it will be skipping the slow path and it will be moved to the fast path. Okay, this slow path is mainly for session installation, and whenever we receive the new traffic or the first packet from the traffic, so first packet from our traffic, it will be moving to the slow path. Okay, what will happen in the slow path? Okay, the first thing the slow path will be doing is an forwarding lookup. Okay, for what is forwarding lookup means? Forwarding lookup or route lookup. What it will do in the forwarding lookup or the route lookup means, we have extracted the destination IP here, right? We have extracted the destination IP. What it will do is it will be checking, it will check the route to the destination. Okay, it will check the route to the destination. That is where forwarding lookup happen in the slow path. So if route is there in the routing table, మనకి అక్కడ రౌటింగ్ టేబుల్లో ఆర్ ఇక్కడ ఫార్వర్డింగ్ లుకప్ ఆర్ రౌట్ లుకప్ జరుగుతుంది కదా, ఆ టైంలో నీకు ఇఫ్ ద రౌట్ ఈస్ ప్రజెంట్ ఇన్ ద రౌటింగ్ టేబుల్, ఓకే, it will be checking the what is the exit interface, right? Maybe in the routing table we create the routes, we are having then next hop, or we will be adding an exit interface. Here in the firewall we are using an exit interface. Okay, to which exit interface it has to be exit, right? We are adding this ethernet 1/3. Okay, so from the routing table we'll be check if the route is exist or not. If the route is exist, we'll be looking for an exit interface. Okay, exit interface. From the exit interface, what it will do is it will be extracting the destination zone. Okay, so the seventh tuple is the destination zone. In the ingress stage, it will be extract the 6 tuples, and in the slow path it will be extract the seventh tuple is an destination. So we'll be having 7 tuples now: source IP, destination IP, source port, destination port, source zone, destination zone, and the protocol. Okay, after the forwarding lookup, what it will do is it will do a NAT lookup. Okay, do you know the NAT, right? Network address translation. Do you have any idea about the, sorry, NAT, network address translation? Anyone know about the NAT? Okay, sure. I will let you know. Yeah. Why we are using NAT means, here NAT is an network address translation, where our private IP address are translating to the public IP addresses. Okay, for suppose if you see, whenever you are going to the internet, we don't want to expose our private network. For suppose we will be having a topology like this, and we are having a private IP address which are using in inside, and we don't want to expose our private IP addresses. Okay, this is, let's suppose this take our private network is 10.10.10.10, and we are trying to reach internet, right? Whenever you are trying to reach internet, we don't want to expose our private information, okay? Private API, private subnet information or private network information, because in the internet many users are sitting and many hackers are also sitting. If they want try to access your network, they will easily tries to access your private IP address, okay, without NAT. Whenever you are doing NAT, what it will do is it will be translating your private IP address to some of the public IP addresses, okay. Here the firewall will do a NAT at this interface. Whatever the IP address that we have configured here, the interface that are connecting towards the public will be using that interface for the NAT purpose. We are configuring public IP address here, okay. Whenever this traffic reaches the firewall, what the firewall will do is firewall will be converting our translating our private IP address to public IP address. For suppose for suppose we have a public IP address like let's take 212.13.14.1, okay. What it will do is it will be translating our public private IP address to the public IP, and it is sending the traffic out, okay. Because in order to protect or in order to conserve our private network, we need to use an network address translation to protect our private network or private IP address from the public. Or if you want to reach the public, we don't want to expose our private network. So that is the reason we are doing the NAT here. In the NAT, we'll be having two types of NATs, okay, source NAT and destination NAT. We have an source NAT and destination NAT. What happens in the source NAT and what happens in the destination NAT means, whenever traffic moving from our inside network to outside, we'll be doing an source NAT, okay. Here we can do an SNAT. And in the reverse process, whenever traffic coming from outside to inside, we are doing an destination NAT. We'll be calling as an DNAT. What will happen in the source NAT means the source IP address is translated to the public IP address, okay. And in the destination NAT, the destination IP is translated to the public. Our destination NAT is translated, okay. Here in the slow path, the NAT lookup will be happen, okay. If we have configured and source NAT, what it will do is it will just check for the NAT allocation, and it will be proceeding further, okay. It will just check for NAT allocation, means whether we have allocated the public IP for that particular source IP or not. It will check the NAT allocation and it will be proceeding further. The proceeding further in sense we are having a third step which is an policy lookup, okay. And if it is a destination NAT, if it is a destination NAT, what it will do means, if you are doing what I told before, if it is a destination NAT, our destination IP will be translated, right? So what it will do whenever we configure destination NAT means, it will convert the destination IP, okay, or it will translate the destination IP, and what it will do is it will do an route lookup again, okay. It will do route lookup again for the translated IP, okay. Because before we have an one destination IP, for that we did an route lookup or forwarding lookup. Now after the translation, the destination IP got changed, right? So for that translated IP, for that translated IP, we are doing again the forwarding lookup, okay. We are again doing a route lookup or forwarding lookup for the translated IP. If we have route for that particular translated IP or not, okay. So here in the slow path, the forwarding lookup will be happen twice, okay. The first forwarding lookup will be happen for our destination normal destination IP. If there is any destination NAT configured, what it will do is it will translate the destination IP, and it will do a route lookup for that translated IP, okay. The route lookup will be happen twice in the slow path. And after that NAT policy, what it will do is it will be checking the policy lookup. We'll be already all having this all the tuples, right? We'll be having 6 tuples here and we'll be having 7th tuple here. With this 7th tuple, it will be going with then policy lookup. If any policy is matching with these tuples, okay, we are configuring policy in the firewall, and if any of the policies matching with that with these 6 tuples, and it will be checking the action, okay, it will be checking the action in the policy. If it is an allow, okay, if it is an allow, the firewall will allow the traffic, okay. If it is an deny, okay, if it is an deny, the firewall will discard the packet here and it won't process further. It will be depends upon the security policy that we have configured. If the policy is configured set to allow, the firewall will allow the traffic, otherwise the firewall will deny the traffic, okay. And here in the policy lookup, there are two types of actions, okay. The actions are different types. We'll be having allow, deny, drop, reset both, reset client, and reset server. These are the type of actions that we can see in the security policy, okay. If it is an allow, the firewall will check the matching policy, and if the action is set to allow, the firewall will allow the traffic, okay, and the firewall will send the traffic code through the exit interface, okay. If it is a deny and drop, okay, there is slight difference between deny and the drop. The both actions will be same. If you configure a deny, the packet will be discarded. If you configure an action as drop, the packet will be discarded. In both times the packet will be discarded. But there is a slight difference between deny and the drop. Mean what the difference means? Whenever you configure an action as a deny, what it will is, the firewall will discard the packet here, and it will send an error message, okay. ICMP unreachable error message will be sent whenever you set the action as a deny. When you set the action as a drop, the firewall will silently discard the packet. It won't send any error message to the source or client. It will simply discard the packet without informing anything, okay. This is the basic difference between deny and drop. And when you send reset both, it will send and reset both to the client and the server, okay. It will send reset, and it will send reset to both client and server. And if it is reset client, it will just send and reset client to the client, and if it reset server, it will send and reset server to the server, okay. These are the type of actions that we have in the policies, okay. I will show you once whenever we are creating an policy. I will show all these actions, but you have to remember what is the basic understanding of these actions, okay. And after policy lookup, if action is set to allow and the firewall is trying to send the traffic out, so what it will do is, the session will be installed, okay. After the slow path, the session will be installed in the flow table or session table, okay. The session will be installed in the flow table or session table, okay. That is why if there is no existing session, the the firewall will send the packet to the slow path stage to process and to install the session. If already the session is exist in the session table, it won't comes to the slow path, it will be going through the fast path, okay. And once the session is installed, and it will be available in the flow path flow table and session table, and it will be moving to the next stage called fast path, okay. Fast path, what is the fast path means? This fast path is mainly for already existing sessions, okay. Whenever there is an existing section, whenever the return traffic coming from outside, for suppose if you are sending TCP SYN TCP packet, it will send an TCP packet first, okay. TCP packet first, and SYN packet, and it will be receiving a SYNAC, right? So whenever you are receiving SYNAC packet from outside, it will be going with an fast path, okay. It won't go with the slow path, it will be going with a fast path. what will happen in the fast path means it will again do an L2 to L4 processing, okay, because this is an existing, this is return traffic, right? For that return traffic, what the firewall will do is firewall again do an L2 to L4 processing, okay, and it will also again check for any errors for in that L2, L3, L4 packets, and if there are any errors, the packet will be discarded and it won't process further. And if there are no errors, what it will do is it will again check for the NAT policy, if there is any NAT policy configured for this return traffic. If it is a NAT policy is configured, it will be checked whether it is an source NAT or a destination NAT. Okay. If it is a source NAT, it will just check for the IP allocation and it will translate the source IP and it will process further. And if it is a destination NAT, it will be translated again. The packet is translated, right? So the IP is all the IP, the destination IP will be translated. So for that translated IP, okay, it will again go for the forwarding lookup. This is the third forwarding lookup in this process, okay. Again for that translated IP, the forwarding lookup will be happen and the packet will be proceed further, okay. And again in the fast path, what it will do is if after doing a destination NAT and after looking for a NAT policy, what it will do is it will be checking if there are any SSL proxies configured or not, okay. SSL proxy is configured or not. If SSL proxy is configured, it will be in the SSL proxy. What it will do is the packet will be decrypted, okay. It will be checking for any decryption policy. The SSL proxy will be having a separate session, okay. We'll be having SSL decryption class, so you will be learning more about that SSL decryption in that. What is SSL decryption? We'll be having multiple types of SSL decryptions. We'll be learning both in that class, okay. You can just remember what are the things that happening the fast path, okay. And in the SSL proxy, what it will do is it will check for any decryption policy configured. And if decryption policy is configured, the firewall will decrypt the traffic and it will identify the application, okay. Whenever you are browsing something on the internet, it will be using HTTPS, right? HTTPS means it is an SSL traffic which is in the secure manner, okay. So whenever the traffic reaches the firewall in the secure manner, the firewall has to decrypt to know whether the application that customer is using. For suppose if you are using HTTPS // facebook www.facebook.com, whenever this traffic reaches the firewall, and that is an in a secure way, that is an in the encrypted format, right? So what the firewall is, the firewall will decrypt that and it will be checking the application, okay, and it will check for the application, okay. If the application is identified here, the what the firewall is, firewall will be having an its own application database, okay. The firewall will be having application database where it has all the application signatures, okay. It will be matching with the signature, and if application is identified with this signature, and it will skip the application identification stage. We'll be having after path we will be having the application identification stage, right? If the application is identified in the fast path itself, okay. If the application signature is identified in the fast path, the firewall will skip the application identification stage, okay. If you don't have any application signature, okay, for that particular for suppose if you are browsing www.snapchat.com, if that particular signature is not identified in this process, what it will do is it will be moving further to the application identification stage, okay. If the firewall has application is database and it is matching its signature, and it will skip the application identification, okay. And if the application is not identified, it will move into the application identification stage. In this application identification stage, what the firewall will do is it will check if there are any custom application is there or not, okay. If the custom application is created or not. custom application means uh, it is manually creating. We have an authority to create an applications manually also. Okay, if there are no application, if there are no applications in this firewall application database, we'll be able to configure a custom application. And if it is a custom application, what it will do is the firewall will be check for if any custom application is created. If the custom application is created, it will check for the application override policy. Okay, we'll be having application override where it will bypass the L7 inspection here. Okay, this application override is useful to bypass the L7 inspection, because we have already, if firewall is identified on its own, the firewall will do an L7 inspection, but we are creating a custom application manually, right? So by if you are creating custom application, we will be configuring application override as well, because it has to be by the firewall. We are bypassing the firewall to for the L7 inspection. Okay, so in this case, what it will do is, if the application override policy is identified, what it will do is, it will be going with an policy lookup. Okay, it will be going with an policy lookup for the custom application, whether if there are any policy for this application or not. Okay, if the policies matches, and whatever the policy that we have created, and if the policy matches with this application, the firewall will process that application further. Okay, the firewall will able to identify that application, and it will be processing further. Okay, if the policy is not matching, okay, if the policy is not matching, and also if you have configured an policy with the action deny drop, the firewall will drop the traffic here, and it won't process further. Okay, in the application identification stage, the policy lookup will happen to check whether this custom application is allowed or not. If it is allowed, it will be send the traffic, and if it is not allowed, it will be deny here. It won't process further. Okay, and after policy lookup, what it will do is, it will be going with an content inspection. What the firewall will do in the content inspection? The content inspection mainly for we have identified the application, right? For that applications, it will be going for that whether there are any threats. Okay, any threats or vulnerabilities, or any malware detected. Okay, for malware detection, or if there are any hacking, if there is application is from the hacking. Okay, so the firewall will go with the content inspection, and it will be going with an these checks. Okay, if there is any threats on the particular application, or if there are any vulnerabilities identified, and malware detection, if that is belongs to the hacking, it will be going with a content inspection. And if nothing is identified, the firewall will proceed further. If any of these identified, if there is any threat detection, if there is any threats identified on that, the firewall will be drop the traffic, as well as if there are any vulnerabilities identified, or if there is any malware detected, the firewall will drop the traffic, and it won't proceed further. Okay, and after that content inspection, in the not after that, in the content inspection, what it will do is, here if you have in the application, in the fast pass stage, what we did an SSH proxy, right? In the if SSH proxy is configured, it will be looking for the decryption policy, right? Here the the traffic is decrypted, right? So what content in the content section, what the firewall will do is, for that SSL for that SSL traffic, whatever the traffic the firewall is decrypted, it will be re-encrypting that. Okay, whatever the SSL traffic is decrypted there, the firewall re-encrypt the traffic here in the content inspection, and re-encrypted the traffic, and it will be moving towards the egress stage. Okay, in the egress stage, this is the last stage Once all the stages is passed, and it will be receiving in the egress stage. Okay, in the egress stage, what the firewall will do is whatever the traffic receiving on the ingress stage, how the traffic is receiving in the ingress stage, the same way we have to send the traffic out, right? In the initial step we have discussed about the tunnels, right? If we have any IPsec tunnel or SSL tunnel or any other VPNs configured between this client and it, the firewall will decrypting here, right? So how the traffic is received, the firewall receives the traffic in the form of encrypted, and to inspection it will be decrypted traffic. Okay, however, the firewall receives the how the firewall receives the traffic on this egress ingress interface. In the same way, the firewall has to be send the traffic out, right? So what it will do is, if there is any IPsec tunnel decrypted, it will be the tunnel will be re-encrypted here. Okay, if that is a tunnel traffic, the tunnel traffic is re-encrypted here. Okay, the tunnel traffic is re-encrypted, and after the re-encryption, if any cause policies is configured, if any cause is configured, the cause is applied here. Okay, applied in this stage. Cause means this is a quality of service where you can limit the bandwidth to the particular user. Okay, if you want see you have a bandwidth of 100 mbps. Okay, you have a bandwidth of 100 mbps, but you want to limit the for the users like 20 mbps. Okay, you want to limit the bandwidth for the users, but the users want to use only the 20 mbps out of 100 mbps. Okay, so in that case what we can do is we can create an quality of service which is an cause. So we will be calling we will be assigning that cause with this 20 mbps and assigning that cause profile to the user connected interfaces. Okay, mostly the cause will be doing on the egress interfaces only. Okay, because whatever the traffic going out whatever the traffic going out will be going out with the exit interface, right? So mostly cause will be configured on the exit interface, so that we can limit the bandwidth whenever these users trying to use. Okay, so if any cause is configured, the cause policies are applied on this stage, and if any fragmentation happen. Okay, in in the initial stage, if any fragmentation bytes received, the firewall uh, will uh, will do not fragment that, and it will be combining all the fragmented packets here to inspect, right? Okay, if any fragmented packets received, it will do again fragmentation here in the egress stage. Okay, it will do an fragmentation again, and it will be sending out the packet. It will send out the packet from the egress interface. Okay, this is how the packet will be inspected inside the firewall. Once the packet receives, what are these are the stages that are going to the firewall will be going through this, and the firewall will be inspecting each stage, and if any of the packet is does not pass the stage, the packet will be dropped on that stage itself, it won't proceed. Okay, until unless these stages are passed or these stages are successful, the packet won't be egressed out through the egress stage. Okay, I think this is all about the packet flow. And do you have any questions or do you have any clarifications on this? యా పాలసీస్ అంటే ఐ మీన్ మనం ఇది ఇన్సైడ్ ద ఫైర్ వాల్ కాబట్టి మనం ప్యాకెట్ క్యాప్చర్లో చూడలేము. వీ హ్యావ్ ఎన్ డిఫరెంట్ సెట్ ఆఫ్ కమాండ్స్ దేర్ వీ కెన్ సీ దట్ బికాస్ వాట్ ఎవర్ వీఆర్ డీలింగ్ దీస్ స్టేజెస్ దిస్ ఈస్ ఇన్సైడ్ ద ఫైర్ వాల్. ఓకే, in the inside the firewall we can't capture that, but there are some set of commands that I will show you if you want. Okay, Yeah, but these are the stages, and these are the steps that are going for every traffic. The firewall has to be gone through these stages. Okay. Yeah. No, no, no. This is especially for the Palo Alto only. The if you want to learn other firewalls, there will be some different stages or different packet flow. This is especially for the Palo Alto only. Yes. Yeah. No issues. Yeah, actually, we debug commands and we high level commands. We cannot use that high level commands in this. Okay, if needed, I will grab that and I will show you personally. Okay, what are the stages that it is going through this. Okay, but in the packet capture, we can't see because this is not happening on the Ethernet, right? It is not happening on the Ethernet. It is inside the firewall. We can't see that. Hmm. Yeah, yeah, I will tell you if that is an troubleshooting. I will tell you the troubleshooting steps as well. Okay. How can we troubleshoot if we face one issue, or how can we proceed further? Yeah. And apart from this packet flow, we'll be having session states. Okay. How the sessions will be forwarded, and how the session states are formed. We have seven different types of session states here. Okay, for every firewall we'll be having some fixed number of sessions. Okay, for PA 200 PA 400 series firewall we'll be having like 20,000 to 30,000 sessions. Okay, it will be supported 20,000 sessions only. Apart from 20,000 sessions, if any new session comes, the firewall will not able to accommodate that. Okay, so for suppose if we go with the session states, we'll be having session states. Okay, the first state is an free state. Okay, and in that free state, what it will be there is the session will be in the free pool. Okay, we'll be having free pool. The session will be, if the session is in free state, it will not be in any the session is not accommodate in any state, in any traffic or for any sessions, and it will be stays in the free pool. Okay, it will be ready for the session if any traffic receives on the firewall. One of the session will be from the free pool, one of the session will be assigned to that. Okay, if it is an, here we have transition states and stable states. I mean, we have four transition states and three stable states. Okay, transition state means we cannot see those states on the firewall. Means it will be transmitting, it will be in the transmission within a fraction of seconds. Okay, if it is an free pool, the session will be in the free pool, and if there is any session, if there is any traffic received on the firewall, the default the default state is an init state. Okay, we can see this init state. Okay, this free state is an transition state. We cannot see with our eyes because it will be transit in fraction of seconds. But init state is an stable state. Okay, we can see this stable state because it will, this state will be stays for until we have an active session. Okay, in the init state, what it will do is it will be whenever the traffic receives. Okay, if for suppose if we send an TCP traffic, whenever we receive the TCP SYN, the session will be moved from free state to the init state, and this is this state that this is the initial packet of that particular session. Okay, and the next state is an opening state. Okay, what it will do is it is also an transition state. We cannot see this opening state. Okay, and what it will do in the transition statements, after after SYN packet sent and before establishment of our session, it will be moving to the opening state. Okay, before establishing our active session. what it will call as before establishing the session, it will be in the opening state. Okay, the next state is an active state. This is a once we completely done with an synac act. Okay, what it will do is it will move to the active state, and if any policy matches, and the policy is set to allow, and set to allow, the firewall will be in the active state. In this active state, the firewall will actively monitoring the traffic. Okay, whether the firewall whenever the firewall matches this policy, and we have set the action as an allow, the firewall will move to the active state from opening state. So the firewall will be actively participating in the traffic and monitor that particular traffic. Okay, and the next is an discard state, where if the traffic receives, okay, whenever the traffic receives on the firewall, and if the policy matches, and set the action as drop or deny. Okay, set the action as drop or deny, the firewall will be in the discard state. Okay, because we are denying the traffic on the firewall, so that session will be in the discard state. Whenever you see the discard state, you need to check the policy whether any of the policies matching with the action drop or deny. Okay, and the next stage is an closing state. Okay, after completing successful transmission of the data. Okay, whenever you form an TCP session, right, after TCP session, the client and the server will be able to send the data. Okay, and once if the client think that I'm finished with the sending of the data, what it will send, it will send an fin bit, right? Whenever the firewall sees the fin bit from any of the source, any of the from client or the server. Okay, from client or the server, it will be moving to the closing state. In the closing state, it will still monitoring the traffic. Okay, in this stage, the firewall will still monitoring the traffic, whether the firewall is completely closing the session or not. Okay, or whether we have received a complete fin bit from other side as well. The next stage is an closed state, where the firewall receives the fin bit from other side as well. Okay, fin bit from both the client and server. Okay, the closing session will be if the firewall sees fin bit from any of the client and server, and it will move to the closing state. In the closing state also, the firewall will be monitoring the traffic unless the session is closed. The firewall still monitoring the session, and if it is a closed state, the firewall has received the fin bit from both client and server. So the session will be closed. Okay, whatever the session that firewall is assigned for this traffic, the session will be closed, and this session will move to the free pool again for another traffic. Okay, this session will be moved to free pool. Okay, these are the 7 state. I will show you while we are doing a lab. Okay, I will show you these states, but these transition states we cannot see. We have 4 transition states, right? The free state, opening state, and closed state and closed are also, these are also transit, these two are also transition states. But init, active, and discard are the stable states, where it will be stable in this session for some time, that we can see these sessions. Okay, if it is an active, the firewall will actively participate in the traffic and the policy matches. If it is a discard, the firewall denied the traffic with the policy match, as an action denied the drop. Okay, These are the seven sessions that are in the Palo Alto Firewall. Any questions or any queries on these sessions? Any questions or any queries? Hmm. సి మనకి ఇక్కడ ఆల్రెడీ ఫైర్వాల్లో సెషన్ మెయింటైన్ చేస్తుంటుంది కదా, ఇక్కడ సెషన్ మెయింటైన్ మనకి ఎప్పుడైతే క్లయింట్ అనేది మనకి సేమ్ సెషన్ మన సేమ్ ట్రాఫిక్ సెండ్ చేసేటప్పుడు అది సేమ్ సెషన్కి హిట్ అవుతుంది కదా. ఇప్పుడు సెషన్ ఈస్ యాక్టివ్ అండ్ ఇఫ్ ద సేమ్ ట్రాఫిక్ ఈస్ హిట్ ఇన్ ద సెషన్, ఇట్ విల్ బి యాక్టివ్ ఆల్ ద టైమ్ అంటిల్ ద సెషన్ ఈస్ క్లోజ్డ్. యా. ఎనీ అదర్ క్వశ్చన్స్? Yeah, and we have an last topic in this firewall fundamentals, and which is an interface management profile. Okay, మనం నిన్న ఇంటర్ఫేస్ టైప్స్ గురించి డిస్కస్ చేసాం. ఇన్ ద ఇంటర్ఫేస్ టైప్ వీ హ్యావ్ డిస్కస్ అబౌట్ మేనేజ్మెంట్ ఐపీ, రైట్? మేనేజ్మెంట్ ఇంటర్ఫేస్, where this management interface is helpful to access the firewall, web GUI or SSH, right? For suppose I lost the access to the management interface, okay? For some reasons I am not able to access the web GUI because the management interface went down or management interface is not accessible. In that case we cannot able to log into the firewall, right? Mostly the firewall or all the network device will be able to manage from the management interface only. Okay, we log into SSH or GUI through the management interface IP. For any reason I lost the access to the management interface and I am unable to access this. So in that case, if you want to log into the firewall through GUI or SSH, there is an option called interface management profile, where you can enable the services in the interface management profile. Okay, we'll be having multiple services like HTTPS, okay, and HTTP. We'll be having SSH, okay, and we'll be also having ping, we are having SNMP. All these services are available in the interface management profile. Okay, you need to configure an interface management profile in the firewall. If you want to access web GUI, means this is an HTTP or HTTPS, right? You need to enable HTTPS or HTTP, but our firewalls will be able to access through the HTTPS. Mean we have to enable the HTTPS, okay, and we need to, whenever management interface management profile is configured, so what we need to do is we need to add that interface management profile on any one of the data plane interfaces, okay, any one of the data plane interface or in-band interfaces. Okay, so whenever we lost the management interface access to the management interface, we'll be able to access the firewall web GUI or SSH through the data plane interface by enabling the interface management profile. Okay, interface management profile is a thing in the Palo Alto where you can enable the services, whatever the services that you want, through the data plane interfaces. Okay, these all the services mainly using from the management interface. Once this management interface goes down, we cannot able to access these services, right? So in order to access these services, we are enabling the interface management profile and calling that in the data plane interface, and we can use these data plane interfaces for whatever the services that you want. If you want HTTPS, you can enable HTTPS and add this management profile on this data plane, so that it will use this HTTPS on this data plane interface. Okay, so this is mainly for redundancy for the management interface. If you lost the management interface, we need to again go to the data centers. We need to connect the console cable. We need to log into the firewall. What we need to check what happened to the management interface. Instead of going to the data center, we are sitting somewhere else in the remote. So we cannot simply go into the data center, right? So in order to avoid that, or in order to have the redundancy to the management interface, we have an interface management profile. Okay, this is the purpose of interface management profile. I will also show how we can configure this interface management profile, and how to add that into the in-band interfaces or data plane interfaces. Okay, any questions on this? With this, our firewall fundamentals are completed. Okay, I think Venkat garu మీరు you joined today itself, right? Okay, okay. Yeah. Yesterday we have completed some of the fundamentals. నేనేం చేసా అంటే మీకు రికార్డింగ్ వీడియో షేర్ చేసా. You can go through the recording video. Okay, yesterday's one. Let me know if you have any questions or queries. Okay. And after this class, I will be sharing this recording as well in the group. You can also go through this video, and you can just let me know if you have any queries. Yeah. Yeah, guys. Any other queries before stopping the recording? యా యాక్చువల్గా నేను ఈరోజు కొన్ని లింక్స్ షేర్ చేశాను. అంటే మీరు జాయిన్ అవ్వకముందు షేర్ చేసినట్టున్నా. ఐ విల్ ఆల్సో షేర్ వన్ మోర్ టైమ్. ఓకే, నేనే అంటే ఐ మీన్ వీ హ్యావ్ టు సెటప్ ద ల్యాబ్. మీ దగ్గర అందరి దగ్గర ల్యాప్టాప్స్ ఉన్నాయి కదా? యా. సో నేను ఒక వీడియో షేర్ చేస్తా. సో యూ కెన్ మే యూస్ దట్ వీడియో యాజ్ ద రెఫరెన్స్ టు సెటప్ PaloAlto lab in your laptop. Okay, and whatever the software that needs for this lab setup, I will share, and you can install and download and install and using the reference video. If you have any problems, we can discuss tomorrow. Okay. Yeah. Okay, guys, if you don't have any doubts, I'm stopping the